Alright, this is video assignment number 2. I realized the first video had some problems on the first set of problems. I don't know why it didn't record as I scrolled down. Hopefully this goes better, and you don't need to worry about those two problems. This assignment should be not too difficult. It just has one objective, and that's that you qualitatively describe a solution of two compounds. Qualitatively means no numbers. So I just want you to be able to describe what happens in the beaker when two things are added together. So let's go to the next page and we'll talk. So what I'm going to do first is I'm going to take base, NaOH, and I'm going to add HNO3. And what I want you to do on each of these assignments, I just want you to draw a beaker, and I want you to write in there what's going to be in there. All right, and then I want to it'll be a little bit strange, but I want you to write the size relative to its concentration. Like if there's a lot of concentration, write it big. So we'll just do this example. When a base and an acid meet, it's a neutralization reaction. So I get NaNO3 plus HOH. Now both those are aqueous or soluble. So really all I have in here is water and Na plus and NO3. But there's also just one little trick here that we'll have to talk about when we get into kind of the math side. So all I'm looking for now is that you indicate that right now we have Na and it's in a certain concentration, and NO3 and it's in a concentration that is equal. So I would write their font sizes roughly the same. All right, and you're just going to write this in pencil, but then our third thing that we would have in here is HOH. Now this one's super easy. They should all be the same size because when this balances out, it's all ones. So we don't necessarily have to worry. I would have to tell you how much of each thing was present in order to know exactly, but their concentrations will all be equal. If we get into something a little bit harder, then I want to show you what I mean by different sizes of letters. All right, so this one will be a little bit more difficult. Let's draw our beaker. Universal sign of water is the squiggly line. I've gone ahead and completed this. I better balance it also. So I'm going to have a 2 in front of NaCl, then a 2 in front of here, and then the rest are 1s. So now what I want you to write in the beaker is I want you to put this little like chunk thing down here, and that represents your precipitate. So I would want you to indicate that you know the precipitate is PbCl2. Then I want you to write what's in the beaker. And what's in the beaker are my spectator ions, and we're just going to have the two spectator ions in the solution, which are Na plus and NO3 minus. I got interrupted by my children, so I might have skipped a little bit, but hopefully that makes sense. And once again, since we don't know the initial amounts, these are the same size because we can just assume that they were equivalent. But on the next one, we'll add another piece that's just a little bit tricky. All right, so I've written this equation. I've drawn my beaker. And I don't want to get mathy here at all because I said qualitative, but I want to kind of introduce the concept of the stoichiometry a little bit. So what I'm going to say, and we don't care about the numbers, but I'm going to say that this is my limiting reactant, and this is my excess reactant. All right. Now we're going to have different size letters in these solutions. So first off, let's go ahead. I'll go to, how about gray? All right. I'll have my chunk, which is my precipitate. You should know that mercury hydroxide is a precipitate. So I'm going to put HgOH2. And I never did balance this. I guess I better do that. So we have a 2 here. And that should, there we go. That should take care of that. All right, so now this is my limiting reactant here, meaning that it's consumed. But this is where we start to introduce some new concepts. This is a spectator ion. So even though it's in the limiting reactant, it's never in the solution. It's never consumed because it stays in the solution. All right, so I'm just going to put C2H3O2, and then I'm going to compare everything to it. Hg plus 2 ion is in the limiting reactant, and it's over here in the precipitate. So no Hg is in the solution besides what's in the precipitate. But OH is the excess reactant, but it's also in mercury hydroxide. So this is where it gets a little bit tricky. There is still some excess OH minus in the solution, but it's just really small. So now with your pencil, you would write OH minus smaller than you would here. That's really hard to do on the iPad, but just know the OH minus is intended to be smaller. I'll just rewrite this one. That'll be easier. All right, so now it's a lot larger than the amount of OH present. And we still have one other thing left in the solution. And we're not going to stress too much about what its concentration is, but it's sodium. It's in the excess reactant, so there's more of it. So it would be even bigger than the acetate. So really, just write the reaction for your assignments. Write the reaction. All right, then draw a beaker and tell me what the precipitate is, and then indicate by size of the way you write things the relative concentration of each part. And you won't have to do the math. I'll tell you whether it's a limiting reactant or the excess reactant. So let's do one more together. All right, so the last one we'll do together is ammonium hydroxide plus copper 2 chloride goes to ammonium chloride plus copper 2 hydroxide. I keep forgetting to balance these at first. So we have a 2, and we should be fine. All right, once again, I'm going to tell you that this right here will make this the excess reactant and this the limiting reactant. And your job is to find the precipitate. All right, and then the concentrations of all the other 3 things. So pause it and take a second to try and do that, and then I'll show you the answer here in a sec when you're done. Okay, the first thing that you should have known is that the precipitate, why do I do this to myself, is copper 2 hydroxide. Hydroxide is always insoluble except for certain things, and copper is not one of those. All right, then we need to find out what is present in a large amount. The largest substance will be the soluble half of the excess reactant, so that would be NH4. And to help me draw, I've got my pen to make some noise. So that will be present in the largest concentration. Once again, because it's excess, which means there's more of it than the limiting. All right, and it's not part of the precipitate, so it's the most abundant. So I'm missing the chlorine. All right, chlorine is part of the limiting reactant, and it's not part of the precipitate. So there's a lot of it, just not as quite as much as the NH4. All right, and the final thing I need to figure out from my excess, which one of the 2 is the one that's insoluble, and that's hydroxide. So there is a small amount of hydroxide left. And once again, it's small, and that should be smaller than chlorine. It's small because some of it's here, but some of it was also in excess. So I'm going to change the chlorine to just a little bit bigger. To hopefully drive that home a little bit more. So there's a couple of concepts that are important that we draw from just this activity. Those concepts will be on the next page. All right, so I summed these up, and it did get mathy, but no big deal here. The assignment is supposed to help you understand the concepts, and then hopefully you can apply the math on the next one. So it says the ending concentrations, the spectator ions will be present in concentration equal to their initial moles divided by the volume of both solutions added together. A lot of kids will do these problems and they forget to add the solutions to find the total volume. The ion that goes into the precipitate from the excess reactant will be in concentration equal to the initial moles minus consumed moles divided by the total volume. And then finally, the ion in the precipitate and the limiting reactant will have a concentration of 0. And remember, that's because that ion really isn't an ion anymore. It's gone in, it's now in a compound that is not ionized, or in solution, I should say. Ionized isn't the right term. Dissociated is the correct term. So it has been completely taken out of the solution, is now solid. All right, so the next three are on the next page. I'll write 3 problems. You don't need to do any of the math. You just need to do one of these and write out the rest of the equation. Okay, for each of these 3, just finish the reaction, balance it, draw your beaker. I guess I should add limiting and excess. Hold on. So those will be your 3 limiting reactants. You don't need to write excess because the other ones obviously are. And hopefully this will help you prepare for the math.